All right, let's dive into what is basically a genuine cosmic detective story. The suspect? An object named 3I/Atlas, and it's only the third interstellar visitor we've ever confirmed in our solar system. This thing is a traveler from a distant star, and its arrival kicked off one of the most incredible scientific debates we've seen in a long, long time.
And that whole debate really boils down to this one single huge question. Are we looking at just a very, very strange comet, or could it be something more? Could 3I Atlas actually be our first solid piece of evidence of technology from another civilization? That's the mystery we are digging into today.
So here's how we're going to crack this case. First, we'll get properly introduced to our mysterious visitor. Then we'll examine all the clues that point to it being an artificial object. After that, we'll flip the script and look at the really powerful case for our natural explanation. We'll weigh all that evidence side by side, and finally we'll get into why this entire debate is just so important for science, no matter what the final answer is.
Okay, so first things first, we really need to appreciate just how special an event this is. We're not talking about some rock from our own asteroid belt here. We're talking about an emissary from the enormous void between the stars.
And when I say special, I mean it. 3I Atlas, which we first saw back on July 1st, 2025, is only the third interstellar object humanity has ever detected, just 3. And what that really means is our sample size for these visitors is tiny. We have almost no idea what normal even looks like for an object that comes from a whole other solar system.
And this is the crucial thing to understand right from the start. The reason 3I Atlas got so much attention wasn't because of one single mind-blowing feature. It was the culmination of weirdness. It was a whole collection of oddities in its path, its chemistry, its behavior, that when you put them all together made scientists stop and go, wait a minute, what exactly are we looking at here?
And that question led directly to our first hypothesis. The really speculative, headline-grabbing one, that all these oddities weren't just cosmic coincidences, but were actually clues pointing to an artificial origin. So, let's look at the evidence that got people so excited.
Get a load of this number. Some researchers calculated that the probability of an object showing up on this specific flight path by pure chance was just 0.005%. I mean, that is an incredibly low number, and it immediately makes you raise an eyebrow. So what was it about its path that was so suspicious?
Well, the case for technology really rests on 4 main pillars. First, that suspicious path. It came in almost perfectly flat with the plane where all our planets orbit, and it made these remarkably close flybys of Venus, Mars, and Jupiter, almost like it was taking a guided tour. Second, it was accelerating in a way that gravity alone couldn't explain, which suggested some kind of engine. Third, and this is wild, during its closest approach to the Sun, it was in a position that made it really hard for us to see from Earth, a very convenient blackout period if you, say, wanted to make a maneuver in secret. And finally, some of the very first images seemed to show jets that were weirdly symmetrical, hinting at controlled engine plumes, not just random bursts of gas.
So you can see why that tech hypothesis was so tempting, right? It connects a lot of those strange dots. But this is where the scientific process really shines. The community didn't just accept these weird anomalies. They started testing them against what we know about physics and chemistry, and they started building a powerful counterargument.
Let's start with that so-called unexplained acceleration. Well, turns out it's not unexplained at all. This is a super well-known thing with comets called the rocket effect. As a comet nears the sun, its ices heat up, turn directly into gas, and shoot out in jets. And just like a tiny rocket, that outgassing gives the comet a little push, changing its path. In fact, this is so common that places like NASA's Jet Propulsion Lab already account for this force in their standard orbital models. It wasn't a surprise at all. It was expected comet behavior.
And we have the smoking gun for what was fueling that rocket effect. Data from the James Webb Space Telescope showed that the gas cloud around 3I/Atlas was just overwhelmingly full of carbon dioxide. I mean, look at this ratio, 7.6 parts CO2 for every 1 part water. That is one of the highest ratios we have ever seen in a comet. And because CO2 turns to gas at much colder temperatures than water, it's a super potent fuel for outgassing, perfectly explaining the acceleration we saw.
So what about those supposedly symmetrical jets? Well, once our best telescopes, like Hubble and the European Space Agency's JUICE spacecraft, got a really good look, they saw something completely different. They observed a classic dust plume, a tail being pushed back by the sun's radiation, and jets that the ESA officially described as being totally in line with a normal comet. No signs of controlled engine plumes anywhere.
But maybe the most powerful piece of evidence for a natural origin is this. Very recent analysis of the object's chemical isotopes, which are just different flavors of the same element, found these highly unusual ratios. These isotopes act like a fingerprint, and they tell a story. And this story says the object formed in an incredibly cold, we're talking less than 30 Kelvin, ancient and metal-poor star-forming region. A place chemically very, very different from where our own solar system was born. This paints a brilliant picture of a natural, albeit very exotic, origin.
Okay, so we've heard the arguments from both sides. We've got the case for a deliberately controlled probe, and we've got the case for a very strange but totally natural comet. Now, let's act as the jury and put them head to head.
This table lays it all out pretty clearly. For every single anomaly, we have two competing ideas. That super unlikely orbit could be a deliberate flight path, or it could just be a statistical long shot. Remember, low probability does not mean impossible. The acceleration, a low-thrust engine, or the well-documented rocket effect, which we know is being fueled by all that CO2 we directly saw. The jets, engine plumes, or just natural outgassing from a spinning comet, which are high-res photos confirmed, and the exotic chemistry, processed materials, or the unique isotopic fingerprint of a comet born in a very different, very cold corner of the galaxy. So here's the bottom line. When you weigh it all up, the current scientific consensus lands firmly on one side. Now, can we definitively disprove the technology idea? No. You can always argue it's just really good camouflage. But the natural explanation is just so much more plausible. It's supported by direct observational evidence, spectra, high-res images, and it explains all the weirdness using known physics without needing to make any huge speculative leaps.
So, case closed? It's just a weird comet. But if that's the answer, why did we even go through all this? Why was this debate so intense and so important? And for me, this is the most fascinating part of the entire story.
It all comes down to this powerful idea. The goal of science isn't to find the most comfortable explanation or to dismiss weird things as fast as possible. The job of a scientist is to take anomalies, the things that don't quite fit, and investigate them with extreme rigor. Because that is where discovery happens.
The story of 3I/Atlas is just a perfect example of the scientific method playing out in the real world for everyone to see. It shows science working exactly the way it's supposed to. An unknown object shows up, you propose multiple hypotheses, even the wild ones, and then you gather data to test them until the evidence points you toward the most likely conclusion.
And just look at what we learned in the process. We discovered that the diversity of objects out there in our galaxy is far greater than we ever imagined. We were reminded that asking bold, unconventional questions is what pushes science forward. We saw that even when the answer turns out to be natural, really scrutinizing an anomaly teaches us way more than a normal object ever could. And ultimately, it really highlighted that sometimes the biggest barrier to discovery is the social pressure to just not sound crazy.
So I'll leave you with this final thought. 3I/Atlas might just be a comet, but the debate it sparked was a test of our scientific courage. It challenges us to hold on to the strange, the unexplained, and the anomalous, because wrestling with those mysteries is, in the end, how we learn what the universe truly has to tell us.